Thanks. I'm Ken Salenza, Managing Director here in Network to Code. I'm going to talk to you about Golden Config, which is an application built on top of the Nautobot framework. Just to reset ourselves for the next two slides, we'll be talking about applications in the ecosystem, as some of you that saw the presentation before, Jason talked about. We're talking about this bottom section here, which is kind of applications built on the primary framework. And just to highlight the agenda, I'm going to go through a problem statement with some of the higher barriers to entry for infrastructure as code. Talk about Nautobot application platform as enabler. Golden configuration solution overview. We'll kind of go through a little bit of the architecture. And then finally, we'll go through the demo, which I think most people will be interested in. Okay, great. So this is kind of a common workflow that you'll see for those getting into infrastructure as code. There's many different variations, of course. But just to describe it a bit here, with a Git workflow, a series of skills you have to kind of know, links, Git, YAML, CI/CD, etc. Typical workflow is, a developer will develop a series of templates. During day-to-day, you update a series of YAML files, create pull requests, configs are generated, configurations are pushed, and maybe manually at first, or probably most certainly manually at first, and then eventually automated as well. And there's just kind of a lot of skills that need to kind of that are required to be able to deploy such a system. And so one of the things we started realizing was how difficult it can be, and that we were starting to kind of capture a lot of the components needed and required to build such a solution and integrate it a bit more tightly within a specific platform. So one of the great things about as we were building out our components here, a lot of the integrations you saw already, as Damien mentioned, GraphQL and the integrations that John alluded to, these components are really making it actually very feasible to have an entire workflow, or nearly an entire workflow, exist within a single ecosystem. And the development process has just been, having developed similar systems for customers before, it's very long, it's a very long process, to say the least. And having all the components, the foundational elements, such as RBAC logging, APIs, etc., and then the new components that were newly added, such as the integrations and GraphQL, really kind of told a new story here of how we could integrate this entire ecosystem. And we really saw the development, drastically improved throughout this building this application. So just want to go over a quick solution overview here. This is more design. We'll get into a little bit more details. It's fundamentally three kind of parts here, and as we go through, you'll see them. The top part here representing the intended configuration. This is your standard Jinja templates and data aggregated together to create configurations. The retrieval from backup configurations, and then the compliance actual comparison of that, right? And what we're doing here is representing what configurations meet your intended state. And I heard Jason and a few others kind of make mention of how do you go about brownfield discovery. And I really think this is part of that story. How do you tell, right? And what this allows to do is network engineers to speak in language that they understand, which is the CLI. Network engineers understand what the CLI configurations are. So really what you're trying to do here is build tooling around enabling individuals to work within the infrastructure as code constructs here. So they could still see CLIs. They're not just seeing data structures, not just seeing YAML files. They're actually seeing the things that they know and been trained on, or CLI configurations, right? So if we dive a bit deeper into the compliance process, what it is we're doing is we're taking the source of truth data, a lot of it coming from within the Nautobot ecosystem through what Damien showed, the GraphQL query language. We combine it with Jinja templates, and then we build the intended configurations. On the other side, the backup configurations are version controlled and represent the actual configurations. Now, we provide the capabilities to do all three of these natively within the platform, but you can actually do one or any of these solutions you want. So if you already have an existing rancid or oxidized backup system and you don't want to use our backup system, that's great. All we require is a Git repository. If you already have an Ansible infrastructure as code generating your configurations, by all means, we could use that. You don't need to change that process. Those investments are not going to go away, right? The third component here is the parser, which does the comparison and understands things like the parent-child relationships that you would get with configurations such as understanding router BGP peers are underneath router BGP, and they belong within that context of that configuration. Real quickly, just a little overview of some of the things, some of the visualizations we'll get here. We'll see this in more detail here. But what we're trying to show here is that we can get an overview of your configuration compliance by feature, what it is that you're looking to get based on your real world data, right? Based on how you actually have intended to configure data, how your actual configurations are in real world. And then we provide overview reports, and then just down here is just to show the idea of the jobs themselves running and the types of jobs that are ran for this process. All right, so I'm going to switch over to the UI here. And what we'll see here, I'll just refresh to make sure we're up to date here. Okay, so we have this UI, which is kind of hopefully very cleanly explain to you what your configuration compliance looks like across your ecosystem, which configuration components are in compliance with your intended state and actual state, and which ones aren't. And we'll see here, I'm going to hone in on this one because it's the one I prepared from the demo, which is the NTP configuration is uncompliant. And before I go into what it looks like, we'll pause here for a second and show what it looks like traditionally. Normally, you can get some kind of Unix diff view of this. And to be honest, this isn't so bad, right? Because this is a prepared demo, and I didn't want to have a big blob of text here, right? The reality is that what you normally get is something like this, which is a whole bunch of text, and it's kind of hard to kind of decode. And this is one of the things as engineers are going through and understanding day-to-day changes, it's often too much information to realize what's going on. So if I go back to here, back to the configuration compliance, and we go to get a detailed view on what's going on with this specific device, we get this high-level overview of what the configurations are, which ones are compliant, which ones aren't. And if we go and navigate to the NTP configurations, we can see here which configurations are intended, which are the actual, and which are missing an extra, right? And if they're compliant, you can just see the configuration that is, because they are the same. They are the same. So, but an engineer can understand here quickly and say, oh, wait a minute, it's missing this configuration. Well, actually, it's technically not missing that information. I just forgot to update my data, right? And so for the purposes of this demonstration, I know what the issue is, which is, as John alluded to before, we have a lot of our data stored in Git repositories, and I know that the data is going to be updated. So we'll go through the process real quick here of synchronizing from Git, which is happening right now in real time, and updating all the configurations. Oh, I chose the wrong one there. So we're synchronized the config context. I accidentally clicked the wrong component. And here you can see that it's loading the actual individual data points from all the different resources that are available, right? Now, that in turn changes the context of what data is represented here, right? Meaning what data we're using in our Ginger templates. So we have a series of Ginger templates, and they're publicly available that you can see and actually you can view them, and you can understand what the components are pulling from them. And you can see now the data is represented to the newly intended configuration, which is 10.2.2.2 for the NTP configurations. What's really nice about this solution is the integration between these various different components. This should look similar to what we saw before, which is the GraphQL query that Damien was showing, right? And so having that access to that data in a single query makes this very doable, right? You build your query, you can update it pretty much at will, and get the additional information you require for an individual device. Okay, great. So now we want to go and rerun the entire compliance check. So this job takes about 15 seconds or so, maybe 20 seconds to run. And it's really those three parts I mentioned before, which are generate configurations, backup configurations, and then compare them, and somewhat sanely, right? There's an understanding of which, based on the customer's definition, there's an understanding of what configurations are like item configurations. Should the AAA configurations be together? Do you consider TechX part of AAA, et cetera, et cetera? What is that view that an individual has? Okay, so that job has ran. We will go back to our compliance, and we'll concentrate here, which is NTP, which hasn't been updated, the window hasn't been refreshed since that job has ran. We will refresh the data. And sure enough, that data has in fact been considered compliant because the data now matches the intended matches the actual state. This can obviously be the corrective action should most likely be to go to the device and update the configuration if your source of truth is good. But what this really allows people to do is that brownfield discovery, stop the bleeding, that type of thing, so that you can get a visualization of what is going on. We've had similar solutions for customers, and they talked about it and said one of their responses is they no longer look at the configuration, they look at the tool. The tool is much easier and quicker to represent the data to them in a consumable fashion. So again, we will go back to this device one last time and see that if we go to NTP, and we can see that the configuration is as intended. Okay, great. One of the component we have here, which is within our config compliance, one of the questions we've been asked before is like, okay, great. Now this is only a few devices. We're only showing 11 devices here. But as this data set gets huge, there's actually it's a lot of data to kind of consume and to understand what is going on. So we developed some specific reports for this compliance aspect and to understand where are configurations going. And I won't go into all the details, but these tell you different components, device versus feature aspects, and you can kind of see from a high level what's going on. Additionally, you can filter out if you understand that the AM region versus the EU region hasn't gone through these data beautification processes yet, and they're not going to be their reporting is not going to work out as well yet. But anyway, really what we're trying to do here is provide the tooling around to make it consumable, and so that people can get that immediate feedback to understand what's going on with their configuration and is their intended state actually matching up with their actual state.
So when I'm looking at this report and I see my configuration has deviated, specifically more so in the version controlled side. Well, obviously that would be where it's at. I guess where I'm really going with this is there a way, does it currently do this? Is there any value or whatever in which where it deviated, does it show a commit where it may have been injected and who by, or is there any value at all from that perspective?
No, there's no integration for that.
Okay.
There's no current integration. There's some vendors I know, like Palo actually, that's 8 release or something like that, started tagging their XML configuration with who last changed it, and you could glean things like that. Others I've worked on, in prior enterprise life, worked to get the daily reports and kind of do some kind of fuzzy match to who send that syslog. Thus, they should have pushed the configuration, but there's no kind of native capabilities. Simply reports what is.
Okay. Thank you.
I know I mentioned before, but it is worth mentioning again. We have these different components. There's really 3 primary pieces that are happening here: configuration backup, configuration generation, and the comparison and compliance of those. You can use one or all of, you can use any one or all of those, right? You might just simply need a backup solution, and this is kind of native to your tooling, great. You may need a configuration generation, great, or you can use all 3. The only requirement is a Git repository in which the various different tools and components can come.
As far as transitioning from Netbox to a Nautobot, do you guys have scripts built for that sort of thing? If somebody wanted to take live data, cut it out of Netbox and into Nautobot to play with it?
We do, and you guys keep me honest, but we have, given the app architecture that we've been discussing, we have a plugin and an app, that would, allow users to ingest data from Netbox to then populate Nautobot.
Yeah, so just to add to that, so basically there's a plugin that you will install in Nautobot, and then you will take a data export from Netbox and feed it into that plugin, and it'll take care of the rest.
Perfect.
And it is worth noting that there's some version pinning requirements as far as dependency goes there. So we forked Netbox as of 2.10.4, version 2.10.4. So that is the data migration path that we're following is from that specific version.